Hey, okay. Wow, long time no see everyone. Yeah, another show, another day. So let's get started. Welcome to OCaml where we bring great developers to talk about OCaml, his script, reason ecosystems, and ask silly questions to them. Here, we try to learn about handling type systems and persons and anything in between. This show is sponsored by your company. Yeah, you can reach out to us and help us promote and this show so we can have more engagement to continue and keep up with the next shows. Yeah, over to Dave.
Yeah, thank you for sponsoring us, the individuals that are doing it. We have a few that are doing it for more than 1 year, which is really amazing. And thanks everybody who connects to the show, show interview, streaming, whatever you want to call it. That's perfectly fine. So I'm David. I work for Hrefs as a software engineer. I'm mostly working on the UI stuff, working on here and there on OCaml, and yeah, that's kind of like my fast intro. And today we're going to talk about a lot of things, but mostly about standard libraries, formal proofs, and of course a little bit of OCaml community. And I think that's time to introduce our guest, which is Simon. Hey,
Okay.
Simon.
Hi.
Welcome.
Thank you.
How are you? How are you?
Okay.
I'm doing really good, really well. Glad to be here.
Yeah, perfect. So, who are you? And yeah, can you make a not so fast introduction about yourself?
Right. So directly into existentialism. Um, I'm French. My name is Simon Cruanes. I've been in the OCaml community for, as I was saying, for like 10 years now. I have background. Okay, I have background in formal logic. So for a while I was in academia or like doing a PhD and a postdoc, and then I moved to the industry side of things, but I'm still working in the same domain, which is formal logic, computational logic, and theorem proving, which are very obscure but very interesting
Nice.
domains.
Yeah, I think about everybody agrees, even if you the work at Imandra agrees that is obscure, makes everybody else feel a little bit better to not understand half of it. So that's definitely a good sign for the rest of us.
Yeah, I think I mean, formal logic is a cornerstone of computer science, but maybe it's one of the less mainstream ones these days. You have so many aspects of computer science that are interesting.
Yeah.
And things like databases or computer graphics are a lot more popular because maybe they've been more directly applicable for a long time.
Yeah.
It's just probably formal logic and like verification are closer to compilers, or they're like adjacent.
Right. Yeah, definitely.
So OCaml is definitely a great language for that.
Yeah, definitely. That's a good one. So like before, guy. So if you were doing the PhD, and you were talking with me before, so that's kind of cheating. So how did you end up doing a PhD in OCaml, and how did you end up in formal proofs?
Right. Well, I've been interested in logic for a long time, but at university I took a course of logic with a teacher who ended up being my PhD advisor, Gilles Dewec. I was in the French engineering school, and then I did a year abroad in Switzerland, did some things, did an internship in the US and blah, blah. And then I contacted back this guy and asked him if anyone was doing PhDs in this sort of logic I'm interested in. And he said yes. So really, it started probably when I was in like the first year of university that I started to get really interested in that. And yeah, it's meeting people and
Nice.
Finding PhD positions. And it's not like a PhD in OCaml, because at the beginning I was like, the topic was really superposition and automated theorem proving. Typically all the provers in this domain are in C or C++.
Okay.
Or, well, most of them, I guess, because it's, performance reasons.
Right.
But I wanted to be able to iterate quickly on that, and C was not great for that.
Right.
Did you say like superposition?
Yeah.
Okay, can you like give a quick intro about
Yeah,
what it is?
I think I know that one, but I won't reply to that one. Well, but I think it's just like go back and explain what is formal verification first, and then jumping on superposition, because superposition is kind of like easy to explain, I guess.
I'm not sure if it is, but I mean, there's it's a very deep rabbit hole for a start.
Okay.
But anyway, so for start, you have two things, right? You have verification, which is really the application of logic to, like, formal verification is the application of logic to the verification of programs, typically, or systems. So you have a program in some language, say C, for example. Actually, it's used for C or Ada. And you want to prove stuff like, in this function, you're going to get an array out of bound access because of some invariance. And so you're going to be able to prove that this integer variable is going to stay between the bounds because, and there's a formal proof, like a logic mathematical proof that it's not going to go out of bounds. It's a very rich domain, and there's lots of techniques.
Wow.
Which are typically, I mean, that's typically used for very critical applications, like, embedded systems in planes, or like automated trains.
Nice.
That's like verification.
So sorry to interrupt, but would you put like formal proof is kind of like the next step or the biggest step of testing? It's on the same rail as testing your software, but in a mathematical way.
Right. In a way, it's like you're testing all the possible paths.
Right.
But you're not doing it with values, because that's, the space is just infinite, but it's just so gigantic that it's, astronomical. Instead, you're using mathematics to say, if I know that, if I know that I is between 0 and 10 and j is between 0 and 10, then I plus j is lower than 20. So access is into this concatenation of arrays, fine.
Right.
Or like bound check, or like you can check overflow.
Right. So usually, like, just to ask more silly questions here, it's like if now you and me sit down in a room and verify all my open source, I mean, that's completely unrealistic. But if we would do that, would go function by function, module by module, trying to find out the formulas of if my code accessing an array or calling functions or methods or whatever are correct based on my assumptions, right? So
yes, verification is a bit of a misnomer. It's well, you don't verify a program, you verify a program with respect to a specification.
Right. The
specification is the logic part. So sometimes it can be kind of fixed. You can say specification is I'm going to prove that this C program doesn't have memory issues.
Right.
Or this program doesn't go into undefined behavior, which is implied.
Right.
But you can also have more elaborate specs where you're also going to prove what your program does.
Right.
I mean, I guess a decent example would be there's a gallery somewhere.
And
I'm going to pass to just a verification tool is Y3, and it's in OCaml, so that's the way I was working on in my internship. And this is about verifying OCaml-like programs.
Right.
So it's you can look at the code and see, okay, there's invariance. There's a formula that say, I don't know, you have an AVL3 module and you say, I'm going to prove that these are balanced. I need to prove that these are search trees, so that they are ordered by the predicate. I'm going to prove that find finds the thing if it's in there. It's very high reliability code. So verification, I mean, you can prove like actual code. You can also prove a model, like you make a higher level model of your thing, an abstraction of your thing, and prove that, which is what we do at Imandra.
So
it's useful. Yeah.
If I'm a company that I'm the NASA or I'm Tesla or I'm like something mission critical, I hire Imandra or use Imandra to verify my code. What kind of errors, aside from memory management, would Imandra find or would myself find?
So Imandra is for verifying models. So currently our applications are more. I mean, we're expanding into various things, but the first application has really been financial exchanges,
right?
Where we take 50 pages of whatever I'm saying, 80 pages PDF.
Okay.
That is a spec. It's like written by a person with a doc, with a Word probably, and turn it into a little program in Imandra that has precise semantics because it's it's very close to logic in a way. It has a logical meaning,
right?
And we can verify properties about that and say even your spec, your spec is ambiguous. Your spec is here. It has this very bad property that you can jump the queue. You can pass an order that doesn't make sense, or you can try something that is not compliant with regulations, which is always a big deal for banks.
Right.
So it's like we're taking this state machine that is the exchange, and we are verifying the model of the state machine.
Nice. So how you end up now that we kind of like know what formal proof verification is theoretically, what's superposition?
Sorry, what?
What's superposition?
Oh yeah. So I was saying this is half of the problem, right? Verification is how you use logic to verify programs. But then to do that, you have to use tools that manipulate logic. And that's, I would say, theorem proving, which is, what you want to do. No, you are wondering how to do it. And so you have various tools and categories of tools to do that, from interactive, like Coq or Lean, which are proof assistants, to like more automated, like SAT solvers, SNIT solvers. And superposition is a technique that is used for the more like automatic part. So it's a technique for taking a formula that you want to prove.
Mm-hmm.
It's a logic formula. It's like a theorem statement, or a logical statement, and you want to find a proof for it. You want to check if indeed it is valid or not, because if it's not valid, you might have a bug. And superposition is such a technique. There's a lot of like subtlety in there. I mean, it's hard to do justice to the domain in a few sentences, but you can think of it as like the most primitive form of theorem proving is SAT solving.
Okay.
Primitive in that it deals with a very simple logic, but it's still very sophisticated because it has like scalability things.
Right.
It's NP complete. It's NP complete problem.
Right.
When I think of like a formal verification, it always comes to mind some highly critical systems like exchange, right? Banks, NASA, rocket science. But there are like more mundane use cases for it, like normal, like not of course normal stuff that you could use it for, like with Imandra, for instance. Like I have an application this one touch like some user states. Is that worth it? Like
today, I don't know. It's verifying is still very hard, depending on what you do. So you have also like more lightweight formal methods like model checking or fuzzing. Well, fuzzing is which might be less costly and more cost effective, I would say. So for verification, really,
I heard that the C compiler is proof verified, or this is a subset of the C language is proof verified.
Yeah,
so
there's a compiler called Concert,
right,
which is developed by Inria. Sorry.
Yeah, no, go on. So for me, superposition was more like you prove a path, and then Imandra, well, because I know Imandra a little bit. So I think you prove a path, and then you don't need to prove neither this path, neither similar paths of that code. But I know you're mixing concepts.
Okay, so yeah, in Imandra we have this thing called decomposition,
Right.
which is not the same.
Right.
It's pretty cool. It's still like it decomposes your state space, like all the paths the program can take, and say if you take this path, here are some invariants, here are some logic truths in this path. Supposition is not really like that. It's just it's a technique for solving goals. It's kind of unrelated.
Okay.
It's it's complicated, but
okay.
Yeah, CompCert is pretty cool. It's a C compiler that is formally proved to preserve the semantics of your code. Right, you write some C program that runs on a plane, say, and you want your compiler to not introduce bugs in it.
Nice.
You want the compiler to keep the semantics of what you wrote, and CompCert does that, and it's a really big project, and it's a research achievement, I think.
Yeah. Nice. So I think one of the things that you are most known, I think, on the Common community, at least for me, was that you maintain containers, right?
Right.
So I think Simon doesn't ring any bell, but C-Cube, I think it's more like kind of like your nickname precedence your person. I don't know, at least like from the Discord, or at least from the if you're new or if you're joined the COML community, what's containers firstly, and how did you create it?
Really, it's just standard library extension, not replacement. Which the goals have always been to be lightweight and performant for what it's worth, but it has always been as a complement to the standard library, as something that you use the standard library and then you use containers on the side for the kind of missing parts, or richer API. And I started it in 2013.
Okay.
So I was doing a PhD. I was like writing a lot of code to experiment with provers, like writing automated theorem provers, and in OCaml, right? And you always find yourself looking for functions that are kind of missing. And back then, the standard library was smaller. Also, it's slowly added functions over time. So at the beginning, it's just like an option module, list module,
right?
Maybe some IO functions. I don't even remember what I started with, like data structures that I missed, like a heap, for example. Yeah,
right.
There's no heap in the standard library.
So, like, my question is more like, when people come to OCaml, a few people complain or are like unexpected. They find something unexpected, which is like a lot of replacements for standard libraries, a lot of extending the standard library, and it's kind of like not everybody, but there are a few versions that they slightly do the same, but not really. So you are a newcomer, you want to, I don't know, transform a list of strings to a list of integers or whatever, and then you look online and you find like 3 or 4 different implementations. Why do you think that's the current status?
Honestly, I think one of the answers is, there are several answers. I think one of them is several of these libraries were started a long time ago when OPAM was not there or was very young. So sharing code was harder. So, say Jane Street had their own code base internally. So they did their own thing. And Batteries was a community library. So, the two were already separate.
Right.
And just using them was not necessarily trivial, You would have to maybe install it here, your package manager, your like apt-get or whatever your distribution was.
Right.
And when I started, so I'm not recall exactly if I looked at Batteries first or if I realized it existed later. But containers and batteries are quite different in philosophy anyway.
Right. Why?
Many things. So the first thing is license.
Okay.
Batteries is LGPL. Containers has always been BSD. These days I use MIT, but I like the really permissive licenses.
Right.
And batteries was like bigger, and if you pulled one thing from batteries, you pulled the whole thing.
That's true.
You know, and
That's
the whole
very
thing would include like Unix and maybe STR. I don't know if it's been a while. And all the modules were, you know, dependent on one another. I was a bit obsessed, I guess, with package weight back then, maybe less now. So container was a bit in reaction to that in some ways, like modules were independent. So if you use one module, you don't put anything else. Modules didn't depend on one another. They kind of do now a bit, but you know, it's still very siloed.
Yeah. So what's the process from pushing standard library? Because I think one of the topics of a language that everybody kind of like hates doing it, or it's super painful that it's never worth it, is discussing the standard library. How is the process in OCaml? Did you were part of it? Did you help? Or
with standard library, I tried to help. I pushed some things in it. For a while, it was a bit harder to contribute to it. I think these days it's easier, but you still have to pass the reviewing. I mean, you know, a pull request might, on a good day, it might go through quickly if it's a small function that everybody agrees on. But if it's a more controversial thing, it might take months, or it can take a longer time.
yeah.
So it's a useful process because my dream is kind of that containers doesn't exist in the future. That is like entirely absorbed by the standard library, you know, or like most of it.
Yeah.
But I don't think it's very realistic. Like everybody has their own taste and design choices. What I do in containers or what we do with, because there's contributors, doesn't always align with the core team's values, right?
Yeah, that makes sense.
So,
but does like aside from the taste, is it as well like benchmark based? Like, do you guys like fight for like, oh, this is ON or this is whatever on each module, or that just like never happened?
I think for the standard library, it's mostly been based on, is this function useful enough to be included? There's been benchmark-based arguments sometimes, but it's often it's or compatibility-based also. I wanted to add something in buffer, and I'm still a bit sad about it, I guess, but I wanted buffer to be closer to the buffer module. I wanted to be able to look at the bytes inside.
Okay.
And people in OCaml didn't want to, in the OCaml core maintainers, they didn't want to break that abstraction.
Okay.
And so that's,
Yeah, just do it in your own, yeah.
Otherwise, it's just, you have to make your case for why you want this in the SDB, in the standard library.
Right. So once you created containers, there was like not OPAM, and then OPAM and Dune. I think, but just like both got very good traction. And how is your opinion on OPAM these days? How have been evolved?
Well, OPAM has been definitely a huge improvement in OCaml. Like there was something before it, which was on Curiosity. I forget the name. There was a thing that was not very used. And OPAM came and it became popular kind of very quickly. And I think OPAM is extremely useful in this respect. Like it's what made OCaml have an ecosystem that people can easily use, which is,
huge, yeah.
Huge. But before that, it was really, I think, mostly like big libraries that you would install through your package manager. You would have like 2 or 3 of them, like batteries and OCamlNet, maybe, but now you can use smaller things more easily. So it's a big progress. That said, I wish sometimes that OPAM was more like, say, Cargo.
Okay.
It's easy to say now, but like one log file by default, something more, more Cargo-like. But I think it's been very. I don't know where we would be without OPAM,
Right. So you are on the side of Dune and OPAM should be the same tool, or not to that extreme, or what's your your vision?
I kind of like the idea of Dune being like integrating some code from OPAM,
right?
Because in a way, Dune project is this one file per project, where you say, here's my project, here are dependencies, the repository, and everything. So if that could directly call OPAM instead of generating and OPAM files and then calling different tool, I think that'd be great. That said, I don't know if it's really realistic.
Yeah, and Dune assumes a lot of OPAM stuff out of the box. So
it does, yeah.
Intrinsically, they are super related tools. It's just like you need to know.
Well, I mean, actually, I think it's like Dune can generate OPAM files for sure.
Right.
When you use an external library, you don't use OPAM, you use OCaml find.
Right.
Which OPAM also uses. So you don't really have to use OPAM to.
That's true. But you need like a OPAM to be the top level, close to your Dune project. So there's a few kind of like hidden rules.
Yeah. I mean, this could be easy to remove. I think it's more how would you manage like constraint. The part of OPAM that is hard to replace is like constraint solving and the fetching of dependencies as far as I understand.
Yeah.
So if Dune integrated that, I think it would be interesting to have like everything in one tool.
Yeah, that's true. Yeah, I think the experience would be overall very good for most things. That's true. So aside from tooling that has been evolved over the past, I think this year, and hopefully this year, and they release it before Christmas. Exactly, it's OCaml 5. So how do you feel about the release? How do you feel about the entire process?
Oh, I mean, the process has been pretty impressive, honestly. Like they merged some gigantic pull requests, that changed almost everything about the runtime and about the CIPI. And I was really on the side. I'm not in the compiler team, but I think they did really an admirable job. And yeah, the whole thing is very impressive because it's not a trivial feat, right? To change the whole runtime, even though a lot of people are ironing out the new memory model semantics, like making sure that if you have a race condition, if you make a mistake and you have a race condition, that is not going to break everything. So something kind of like Java, I think, not like C++.
Right.
And that requires so much work to review the standard library and say, oh yeah, if you have two threads coming in and there's race condition, is it bad or is it terrible?
Right.
You need to break everything.
Right.
So I think that's why it's taking a little while. But I'm very excited for OCaml 5. Like it's
right. Yeah. What's your excitement? Like, I mean, after the release, when it's stable, whatever. What's the first thing that you would do if you install OCaml 5?
Well, honestly, the first thing would be, I think, to port some of my little toy projects to EIO. Right.
So the first kind of like, can you explain what EIO is for the ones that don't know?
So EIO is the chosen one. It's the it's the library that is going to unify async and adaptability.
Right.
It's very interesting. So the main developer is, I think, Thomas Leonard, TEDx X5.
Yeah.
Or someone else, I don't remember. Anyway, it's a IO and concurrence library, both in the same package because anyway. So it's a library that offers first and foremost fibers and structured concurrency. So like routines but structured, I guess. And this is super interesting. I mean, structured concurrency I hope is going to be the big game changer. And it's also IO interface that, IO abstraction
Okay.
that can be either IO ring, libuv, or other things.
Right.
So it gives you like the same building blocks as LWT Unix-ish,
Right.
but a kind of new and modernized package with like streams and structured concurrency. So it's very, very exciting.
Yeah, so I think the thing that we were talking before, like why do we have more than one external library? I think one of the things that is as well funny in OCaml is that we have like more than one concurrency library right now, and they are async and LWT. So
Yes.
like the whole community is kind of like, oh, I'm using one, I'm using the other, or I prefer one over the other. And I think AIO kind of like solves not only like through like the domain and fiber problems as well, like solve like this unification as well. So
well, one hopes, right? I mean,
yeah, exactly.
Like I think it's going to stay for a long time, and probably LWT too, because so much code exists for them.
Yeah.
But I mean, there's two libraries for interfacing EIO with LWT, respectively, async. So I hope personally that that people are going to write code in EIO and interface with existing code using these.
Right.
I don't think Gen3 is ever going to move away from async completely, because they're so invested in it.
Right.
But maybe it will facilitate interoperability.
Right.
I would
so
anyway.
One of the things that I heard is that a few people complain, meaning, oh, CAML 5 feels like Python 3 in the sense of I'm gonna be able to install a library. I'm gonna install a compiled version that allows to not use any of my previous libraries that do IO, because they need to now run or wrapped into their adapter. So EIO LWT needs to be going through all the libraries that you're using LWT. Same with asynchronous. So it feels a little bit of like a breakage in a way. How's that your?
I don't think it's going to be the case, because you can still use existing code, and the core team and OCaml Labs and so on. They're making sure you can use your code basically as is. I think even the thread module is going to stay more or less as is.
Right.
Even though you can use domains now.
Right.
I see it more like the EIO approach, which is OCaml Labs. Anyway, it's more like you can write code for OCaml 5 and still use existing stuff with the LWT bridge.
Right. Yeah. I think that's
great.
Yeah. Yeah, I think that's a good one. Aside from like the features that come from with OCaml 5, this last year or these 2 past years, I have been seeing a thing that I'm really proud, which is that the push of documentation, the new website, the new interface for MLIs, like all of these tooling around community has been there, or at least like a lot of effort into documentation, writing it clearly for like not with a simple terms. What's your view into the documentation?
I think it's making good progress. Like ODoc is becoming the de facto tool, I think, for documentation. It's really a cultural question, right?
Right.
You could write documentation with OCaml doc. It's just, are you going to? And maybe that's where also having an influx of new people is going to be helpful.
Right.
But you look, for example, at even the work done on LWT by Anton. Back in, I'm sorry, I don't know how to pronounce his name. Anton.
Right. Yeah.
It's been amazing. Like he wrote, the LWT.mli, which was just miles ahead of what was there before.
Yeah.
And at the same time, EIO is also being developed with great documentation and testing, which is,
That's
There's a lot
that's
of tests.
actually
It's great.
yeah. I think and the race, like if the level of quality of documentation is Antron, I think all OPAM is like
Yeah.
behind, So yeah, fair to say. What do you think about other communities? Like I think Rust, for example, have the different culture and of course different tooling on documentation. What does Rust, for example, or any other community that you are aware of? We are like you are jealous.
I am just surprised, honestly. Yeah, the tooling is just it's because it's one entry point, right? It's cargo something. I don't have plugin like cargo add to add dependency in one command.
Right.
Of course. So I'm just of course because also their doc strings are in Markdown and there's like doc tests like in Python,
Right.
But that comes also because of hindsight. They came 20 years later, or maybe even more, 25 years later. So they benefited from lessons learned.
Yeah.
But I think ODoc is in a pretty good spot for that now. It's just more a question of doing the work. It's anyway, yeah. I think tuning is there now, especially because also OCaml.org has the documentation of all packages, which is very new, which is something that was missing for a long time. So if you write docs, it's going to be published with cross references on OCaml.org somewhere, and that might be very helpful because otherwise, you could write documentation and then you have to publish it on, say, GitHub pages yourself and link to it. And hopefully this is the part that gets easier.
Yeah. Yeah. That's true. At least tooling is there. I think it's maybe changed a little bit of the mentality. But if you look at what the actual documentation for the language has been done recently, I think that the bar is very high as well. Like the quality of documentation is very good. Do you think that, because you came from academia, or at least like from the more
in the past, yeah,
in the past, maybe you are like reformed now, but do you think that the culture of my documentation is the interfaces comes from the more academic side, or why this culture is more like elitist in the sense?
I think culture and tools are mutually influence each other. So having an interface file where you put your signatures and comments,
right,
that pushes people towards doing that. So also because people rely maybe more than in a dynamic language, they rely more on the tooling to tell them, okay, I have a function. What does it do? You look at the type first, and then with LSP now and Merlin, which also, Merlin has been such a game changer. It's crazy. But with LSP, you can just hover on it and say and see the doc. So it's typically maybe the type-driven development where you write interfaces or types first that influenced the culture of documenting that, right? You're going to write a doc that people read, which is the doc on the function, on the module that you use. And also, I don't think it was easy to make OCaml doc like pages that were not in a module.
Okay.
I think it's doable with ODoc. I just don't remember exactly how, but well, I think Dune has it. But like if you want to write pages of documentation in the same syntax that are not in a module, you have to do a bit more work.
Yeah.
If you want something that is like a tutorial or a
the kind
guide,
of you mean more like the markdown style, like you would like write a paragraph or whatever, and then a code snippet, and then refer to your interface, and this kind of like this blog post kind of a style. That's
and that is also, now we have MDX, OCaml MDX for that. but it's also pretty recent. I mean, it's been, it's been polished, I guess, but to get it to work with a compiled language and libraries and Dune, it's always, some effort.
Yeah.
So I think it's because for a lot of people who were invested in OCaml, maybe in academia, maybe elsewhere, for them, types plus function documentation was enough.
Yeah.
Or they learned that it was enough, or they found ways of making it be enough.
Yeah.
So it's a culture thing.
Yeah. Totally fair. Like once you jump from academia to a professional or industrial work, did you change your perception of the language? Did you, like, when you were more in kind of like doing your PhD on the formal logic, you were like loving more, and then when you're doing it day to day, you're like, that's my tool, I can use any tool? Or do you still like fantasize of the language?
It's like the language as an object, I guess, a bit.
Right.
I would say it's maybe not the transition from academia to industry. It's more like personal maturity of, when you discover OCaml, maybe you're going to be excited about types, excited about JDTs, trying to go full on typing and
right.
try to push as much as possible into the type system, try to use all the tools you have. And with age, I mean wisdom, right?
Mm-hmm.
Maybe I'm more like, let's write simple code that is easy to read and debug, and that I can read in 2 years without hating myself. Or
that's a good reflection. I think everybody passed through the same stages of I want to be type safe no matter what.
Right.
But then later it's like, no, I want to maintain it in 2 years. Like I want to be, it's my own code. I want to not feel bad when I see it, I know, in 2 years.
And like with JDTs, the period where I wanted to write some very sophisticated code with it, and it was a bad idea. Like it was super painful. Every function had to have a generalized like signature. It was a mess.
Right.
And I think we're going to see the same with OCaml 5. That for a year or two,
okay,
everybody's going to write code that uses like effects and domains and fibers.
Yeah.
We're going to be like, oh, that's shiny, I want to do that.
Yeah.
And in maybe 2 years ish, people are going to calm down and say,
Nice.
okay, actually, let's calm down and just
just call a function. Yeah.
Yeah. We can see the same thing, I think, with Go and generics.
Okay.
Like you can see that
generic has been around for 1 year now, I think, or recently, I would say.
Right.
Yeah,
perhaps. All the blog posts about doing like this with Go and generics and that with Go and generics, and then but we do map and reduce with generics, and you're like, no, I mean, Go is not designed for functional programming. It's just going to be ugly, right?
Right.
So maybe we're going to see some super nice effect-based spaghetti for a while, and then people are going to calm down.
Yeah, that's definitely true. So what do you think about like the more advanced features of language? Like, do you say GADT or first-class models maybe, or even functors? I think I kind of like a thing that you might not learn on the first days or weeks of the language. Once you arrive to those more advanced topics, you want to kind of like play around. Why do you think those features are like a shotgun? Like, because you mentioned that you at the beginning you play around with them, you think that it's the solution to all of your problems, and then what happens after?
I think it's like every tool can be overused. In these, like GTs can definitely be overused because there's JDT and JDT. Like using just a small existential type is fine. Down there, it's super harmless. But if you start doing like a DSL with a JDT type with crazy parameters, it's going to be, I think it has its use in like specific libraries that we have the need for it. Like if you do a web router that you want to be type safe, You know, something like where you want a bunch of roots and they have parameters that are integers or strings or URL encoded strings or something like that. GLTs can be very useful for that. But it's going to be, I think, more in the library code that needs them.
Yeah.
And functor, it's kind of the same. Like functorizing everything is a massive pain.
Okay.
Yeah. It can be. If you're trying to abstract too much with functors, you're going to fight with, you know, signature issues. 3 levels deep, where you're saying, oh yeah, this type and that type are not the same, because in another file, another functor, you forgot to alias them, you know, to say, oh yeah, T and food that make the T are the same. And that is just super hard to write, and it's even harder to modify.
Yes.
So
yeah, usually you go to the right call of functors, and then you make all your types abstract to solve those issues, and then at some point being abstract is way too problematic for your problem. Yeah, I think I've been there for sure. Yeah. So one question I wanted to ask is that the creator of OCaml, Xavier Leroy, kind of like moved to COG and moved to formal verification. Why do you think OCaml is a great fit for that? I think one of the things that everybody might agree, and I think everybody in kind of like the software engineering, is that OCaml is a good language to create a compiler or even a parser. Why formal verification fits into the OCaml is good for?
I mean, my understanding, you know, I was not there, but my understanding is that OCaml was literally written to implement COG with it.
Right.
And the family of languages OCaml comes from, ML. The very first ML was also written to be the meta language, as you know, and name,
right,
for a proof assistant in the 70s. And standard ML similarly. So all this family of languages is literally designed to be used for like proof assistants and logic tools and, you know, compilers, because a lot of the things you do in logic are very close to what you do in compilers. You manipulate symbolic trees, basically. You know, expression, formulas, program, that kind of similar.
Right.
So by design is my answer.
Yeah, yeah. I wasn't aware that these two was the direction was the opposite what I thought. One question that now I think is kind of like mandatory these days is like, how do you think AI is going to change how we write OCaml?
I was going to ask that.
Yeah, like the ChatGPT, Copilot, all these kind of whisper or whatever. What's the influence of like machine learning into code, right? Because I think formal verification goes. You cannot formal verificate an AI. I think that's kind of like. I think it doesn't make sense. But how like all the AI is going to change how maybe you work or how many of us work?
That's a good question. I don't have the direct answer. I think it's going to be as useful or useless as for other languages.
Yeah.
I mean, if you could write documentation instead of tests or instead of code, that would be even better.
That's true.
But then you have to proofread it because, you know, it can.
Like you said that it's going to be either beneficial for any other language. Do you think that OCaml has anything different from other languages that the AI can work there? I mean,
if it's
the compiler smart is at least like it's more like our feeling to the compilers that it's smarter than others, but of course with a set of trade-offs. Do you think that this smartness from the compiler would benefit the AI or?
Oh, I think in this direction, I would never want a compiler to include AI because I want compilers to be predictable and you know, simple, fast, and simple. You know, to be like a dependable, predictable tool.
Yeah.
That said, in like if LSP was getting some new features based on GPT-3 or 4.
Yeah, that's actually a good one. Yeah,
I think that would be kind of interesting to see, if you have a type signature, can you try to implement it for me?
right.
Yeah, can you try to write documentation for me? That would be kind of nice, or find examples. That's probably where I would have uses for it,
That's
I
true.
suppose.
That's true.
Like here's a function, write me some tests, write me some property tests if you can. That'd be pretty cool.
Yeah. And apply to logic. Do you think that an AI could guess the verification of a program, or help you, or generate the Imandras verifications?
So some people are working on the intersection of theorem proving and
Right.
AI or machine learning. Maybe in the future, it's kind of hard for AI because it's very language based, right? It's very symbolic, but it's kind of even worse because you don't have meaning to words. Like you have symbols that don't have any meaning,
right?
Except for the formulas. Whereas if you work on language, words are fixed, right? The word like butter always means butter.
Yeah.
It's not like for all butter, blah blah. What's variable? But people are working on that, and I think they're working on trying to solve like math Olympiads with machine learning, for example. They're trying to infer logic formulas from mathematical text, which is cool, like auto-formalization.
Okay.
So I think it's not going to. I don't think it's not going to replace something like Coq or Lean.
Right.
But it might be interesting in, again, complement roles, right?
Yeah. Maybe there's like some, as you said, right? Like on the tooling side, when you are coding, it would help. It would help like in any way. That's true. And if you could just by the type definitions generate stuff for you, or not only like right now, I think all the feature that can be cool is you rename a symbol or you rename a module,
Right.
and the editor like Merlin says, "Oh, this is the same model. Rename everywhere." Kind of like these features, but with steroids. Yeah, I think everybody would benefit for sure.
Or like generalized, deriving.
Right.
Yeah. That could be nice.
Yeah, that's true. On the offside of the interview, when I mentioned PPX, you said, "Oh, yeah, PPX is huge." Do you use a lot of PPXs in Imandra? I mean, in the code base, or?
So we use only a couple. So in the company we use various. We have different code bases. In some of them we use emelletv PPX, I think, because it's very useful to have. In Imandra itself, the reasoning part, the logic core of it, we use mostly just the PPX deriving basics like show and equal and stuff like that, and some custom serialization system.
Right.
I think we're relatively low key on the use of PPX, but we use some.
Right.
Yeah.
Nice. Why do you think are huge? Or
what do you think?
Why do you think the PPX leap helped a lot, and why before was
right?
huge? Or
well, I mean, for me, the PPX is well, first it's stabilizing finally, but I think it's been really a big change because unlike CAML before, which was a thing before, right? Integrates well with Merlin. That's the big deal to me. That's
right.
The big ticket, right? Is Merlin or LSP, OCaml LSP can understand PPX and can understand any PPX, or like at least ignore it,
Right.
Because it's valid OCaml syntax. And that makes a big difference because I think LSP is a wonderful tool.
Yeah.
I think I started using Merlin in like 2013 probably, or 14. Sometime during my PhD, and it was just so great,
Okay.
Like a week in, I I was wondering how I could ever work with that again.
Yeah, because Merlin was way before Microsoft created the language server, right? So Merlin had features that most languages they didn't have at that time, right? Or if I'm mistaken, I was not there on.
Oh yeah. No, so Merlin predates LSP by a long time.
Right.
Merlin I think was started in 2012, 2013, somewhere like that, by 2 university students.
Okay.
And it was like using custom plugins for each editor. If you had Emacs, you had like Emacs, Merlin, and in Vim you had a Merlin plugin for Vim, and so on, with a custom protocol in JSON, I think. But like there was no LSP yet. LSP was not a thing.
Right.
So it was really tailored for OCaml. It has these special actions like destruct. You could say, here's an expression, Merlin destruct on it, and put pattern match.
Right.
It would add the pattern matching. And LSP came, OCaml LSP came much later and built on the same. It built on Merlin really, on the core type system and stuff. Just it is a different way of talking to the editor, but yeah, I think Merlin was just amazing because it was also again like 2 students on their own doing that while doing their computer science bachelor, I think.
Nice. Okay. Yeah, I don't know that. Nice.
Nice. And at some point, they got some support from Gen Street because, I'm sure people at Gen Street were using that and finding it great,
Right. So I think that's kind of like my last question. How do you see OCaml in the next years?
Well, if we was 5 point something at the beginning.
Yeah. What's your? Let me rephrase the question. What's the OCaml 6 roadmap for you?
What? Sorry.
The OCaml 6. Like the kind of like the next version that breaks. What should be on the changelog?
I think OCaml 6 might be when we have typed effects. I'm not sure if and when it's going to happen, but
right.
Clearly they don't want to wait for typed effects to add effects at all.
Right.
Which makes a lot of sense, right? Because that's a research project and it has gigantic implications on compatibility.
Right.
Because I'm not typed effect. Unbox types. I don't think unbox types will require like a major version bump.
Unbox types. Yeah, talking before about the RFCs that never kind of like materialize. I think unbox types fall in that category, sadly.
I don't know. I think they're working on it really at Gen Street.
Yeah.
It has a chance of happening because I think Gen Street is pushing them because of performance improvements. And so they're going to pour a lot of effort into it. And so it has a chance of reaching the same point that multicore did of being seriously discussed for merging, So I'm kind of hopeful for that.
Yeah.
But I don't think it would bump to 6.0.
I think they mentioned the typed effects would be on 5.1. So like...
really?
Wow. I'm talking by memory because I wasn't like I'm talking by memory from the workshop. I think I haven't seen it written anywhere, but kind of like
I'd be able to be proven wrong.
Yeah,
but I don't think it's going to happen. It's going to take a while because I think maybe Jimino, I don't remember who exactly had a talk on that, like a paper on how they would go about adding typed effect to OCaml. Okay. And basically you're changing the meaning of the arrow symbol, the A to B.
Right.
The type arrow would change. It will be like a polymorphic. It will be like actually a squiggly arrow with a variable in there, basically.
Okay.
So it's a crazy big change. Like it would hide. You don't have to change your code in general, but the type checker would have to change how it sees this arrow, which is like crazy.
Yeah, not aware of that.
So compatibility. So the compatibility aspect might be actually very tricky.
Right.
Yeah.
Right. Yeah, I think we have one question more like on the chat, which is the what's your favorite OCaml project of all time?
Oh my god.
Yeah. Yeah.
It's a pretty good question. Man.
Maybe OCaml LSP. I think that's Merlin. I think that's
I
one
mean,
that you
Yeah.
admire
in
the
terms of
most.
tooling, I have lots of things I use that I love.
Right.
I mean, do you know LSP? Indeed. In terms of projects that are
Yeah.
like unrelated, I think Coq is pretty impressive. Like
Right.
it's of course a very big deal, at least in research.
Right.
Yeah. Yeah, we'll make a twist to that question, and then what are like your most interesting, what are the things you find the most interesting being researched on OCaml right now? Like some new stuff people are researching on that are not released yet, or just people playing with stuff, like some interesting like experiments people are doing on top of OCaml.
So you mean on the language itself?
Yeah, yeah, anything like in the ecosystem.
I mean, well, I mean, in the ecosystem, I think EIO is really the thing to look at. I have so there's one thing in it I don't like, which is the fact that you have to pass an environment everywhere because it's kind of capability based, which I think is a good idea, but it's kind of cumbersome. You know, it's a very high. It has friction. But at the same time, the rest of it is just super interesting, and yeah, OCaml 5 stuff, of course, is going to be where people experiment with the new things. So domains lib, EIO.
Yeah.
And in terms of for the language itself, I think what I personally would would like to see come to fruition is indeed unbox types to decrease allocations, you know, get a bit closer to C++ and Rust.
Right.
That could be cool.
Right. As well, they are working on the Lambda too, I think. So one
Yes.
of the works is like we'll get it out of the box. So
yeah, of course, yes. F1.2 is also very interesting. I hope it gets merged. I hope it makes F1. I mean, I hope that F1.2 will be the default switch, right? Because F1 was never ready for that. Because sometimes it just explodes. If you compile some files, it just takes too much time or memory.
Okay.
But F1.2, I hope might achieve that, and that'd be super cool. Yeah.
Nice. Yeah, I think we're looking forward for OCaml 5 and like all the waterfall that later comes with AIO for sure. So Simon, I think we are running a little bit out of time, but it was an absolute pleasure to have you. I hope that you had a great time.
Yeah, it was fun. Thank you for inviting me.
Thanks for coming.
Yeah, it was amazing. Thank you for coming and accepting our invitation. Like, there is some time to answer our silly questions, and yeah, like thanks a lot. Thanks a lot for the chat for participating. I think everyone like I asked them to send their questions beforehand, and then people always send them in the very last minute. But that's how we are. Yeah, that's fantastic. That's fantastic. Amazing. Okay, everyone. Like, thanks a lot for coming up. Thanks again,
Yeah, thank
Simon,
you.
for his your time. Like, it's just fantastic. Hope to see you again. On OCaml 6, or actually before, right? Much before that. And yeah. And again, for thanks a lot for our patrons for sponsoring the show. Like, you help us a lot. You have no idea. If you want to help us, go to our new website, emelletv. So go there, check out the rest of the information. Yeah, that's it. See you everyone on the next one.
All right.
Yeah.
Yeah.
That's it.
You guys.
Bye bye.